can tell you is try to think like a computer. What I mean by that is a computer is stupid. You can see 4 numbers at a time. A computer just sees 1 number at a time. Okay? So if I see only 5, I cannot see what's right or left to me. I only see a 5. Maybe the next one is smaller. How do I know? So think about it. So I'm looking at my first number. Will this be my smallest number? Compared to what? Yes, it will be. Even if my number is not the smallest, if I'm only looking at the first number in my vector, I cannot compare it to anything else yet. So when I execute my for loop for the first time, I need to assign the first number of my vector into my return variable. So how do I know whether it's the first time? I make an if statement in my for loop. How do I know whether it's the first time? If I say I equals 1, because it starts at 1. So if I is equals 1, assign the first number of my vector, but you need to start at some point, right? How can I compare something to something if I don't have a starting point? I need a starting point. And the starting point is the first number in my vector. So you need an if statement. You need an if statement inside your for loop. I told you, you can nest for loops into other for loops. You can nest while loops into if statements. You can nest if statements into while loops, into for loops, and so on and so forth. You're not limited to this. I didn't show it yet. It was deliberate so that you try to tackle this problem. But at the first iteration, I'm assigning the first number of my vector to my return variable. So if I do this in my first iteration, how can I make sure I don't do it in my second iteration? And all the subsequential iterations. How can I make sure that it only happens once? Okay, so let's go over the problem. Now, stop programming for a second and try and let's go over the problem together. So, I'm a computer, and I'm getting a sequence of numbers. You're giving me or providing me a sequence of numbers. All I can do is look at each number one by one. This is the first one. I go to the next one. I see the next one. I go to the next one. I cannot see them all together. So where do I start? At the beginning, right? And I want to get to the end. So how do I go to a sequence of numbers? What do I do as a computer? What kind of structure do I use? Which one did we learn? Tell me, we learned 3. Tell me all of them. If, for, why. Which of those 3 do I use to go over each number in the sequence of numbers? If, no. I hope. So we have 2 left, while and for. Would you use a while loop as long as the condition is true? Or you want to sequentially go over it? That would be a for loop. So what do you have left? The truth is you can make it with both. But the easiest solution is with a for loop. I want to go over each of my numbers that I have in my work vector and look at them. Right? This is what we did before. I printed I so and so many times. Let's do this again. make a for loop from 1 to the length of my vector. So my vector has length 3. I print what I have at each element of my vector. I becomes 1 in the first iteration, 2 in the second iteration, and 3 in the third iteration. If I execute this, I will. 1, 3, 5. This is my x vector. At the first time, I access the first value of my vector x. At the second time, I look at the second index of my vector x, which is 3. And at the third time, there's no more. I look at the last value, which is number 5. Right? Now I want to know which of those has the smallest value. How do I do this? I need a starting point. Okay? So my starting point would be my output variable. At the beginning, I'm telling the computer, reserve space in memory without me telling you what to put there. This is what null tells you. So I need a starting point. How do I start? What is the most logical way to start something? At the end, in the middle, what? At the beginning, right. The beginning was the word. So I'm assigning the first number of my vector to my return variable, but only at the beginning. If I is equals to 1. Only then and never again. So what will be output after the first iteration? My vector is 4, 6, 7, 2. What will be output at the first iteration? What? Don't be so shy. 4, exactly. So now I have assigned the number 4 into output. I want to look at the next value, 6. I want to say, I want to check, is 6 smaller than 4? Is it? No. So I don't change my value that I have in output. I'm going to the next one. Is 7 smaller than 4? No. I don't change my output. I'm going to the last one. Is 2 smaller than 4? Yes. Do I change my output? Yes. And this is what we're going to do. So I only want to do this at the first iteration. So all the other times, I'm going to do something else. Hence, I use the term else. Okay? Now, here, I have to check, is the next number smaller than the number that I have? So what I do, I say if. Okay? I just activated Siri by saying hey. So what if? Is x at I smaller output? xi is 2. What is x2? Is x6 smaller than output? What is output? Exactly. Nothing. So, what do I do? Nothing. I don't do anything. Only if this one becomes smaller, I put it into output. Huh? Ah, yeah. Okay. If it's smaller, then do something. What do I do? I assign output xi to output. Yeah? end my loop, and I return. Again, let's do it again. I is 1. X1 is 4. If I is equals 1, assign 4 to my output. The first time I do something, I have to compare it to something. Else is no. Since I'm already in my if, I'm ignoring the else. So that means I'm going out of my if statement, and I go back into the second iteration of my loop. Now I will be 2. X2 is I equals 1? I is 2. Is it equals 1? No. I will ignore this part. I will go directly into else. Now I have to check. Is xi, which is 2, smaller than 4? X2 is 6. Is it smaller than 4? No. Don't do anything. Don't do anything. Just go out of the if, go back to my loop. Now I will become 3. Is 3 equals 1? No. So I'll go to else. X of 3 is 7. 7 smaller than 4? No way. Again, don't do anything. Go back into my last iteration. I becomes equals 4. 4 is not equals 1. I ignore this part. I go directly into else. X of 4 is 2. Is 2 smaller than 4? Yes. So what do? I assign x4, which is 2, into output. I cannot repeat the loop anymore because I reach the end. I go return whatever is at output to my original function call. And that's the end of the function. And that's a very, very, very simple function. Sorry that I have to emphasize it. I said that. I said that. It's okay. I know it is hard to get your heads around this. I don't remember it anymore. It's been so long that I don't remember. But I imagine it is very hard to think as a computer. But what you have to think as a computer, when I'm saying this, break it down into very, very, it's like talking to a child. Is you tell them, if you tell to a child, after food, you bring your plate into the kitchen, it will not do anything. What do you tell a child? You say, stand up from your chair, take your plate, lift it up, turn around, go all the way to the kitchen. This is how my kids do it. So go all the way to the kitchen, put it on the kitchen counter, turn around again, and leave the kitchen. This is a computer. You have to give it exact instructions of what to do. If you don't give it, I know when you do something on a computer, you don't see what is going behind. But this is exactly a programmer's job, to make it look simple, easy. But this is what is happening behind. And this is a very, very, very small, insignificant, easy function. It can become way, way, way more complex than that. If you go into data structures, network analysis, where you have nested things, and where you iterate, you can call your own loop. You can call your own function. You can repeat the function over and over and over again. That's called recursive function. And then you go back and you go back and you go back and you go back until you get the result. So, okay, let's execute the function. Okay, what do? Save, right. Change from black to red. I need to make it available in my global environment. So I hit the button, source. What you will see now, I'll have two functions available, minimum and sum up, because I have two functions in the same file. So two functions will be available. Let's see what happens if I call minimum without doing anything. I put a default value, right? 4672. what happens? I get the value 2. It works. Thank you. Okay? Let's put other numbers in it. It works. I put 0 as my last number in my vector and return the number 0. That means my function works well. So what I'm not showing you is now I'm assuming that the user only enters integer numbers. What if the user enters letters? So that becomes a nightmare. So this is you only see the core of the function. All the other things, checking whether you're putting in the right casting type, and so on and so forth, is something that also needs to be checked every time. So therefore, programming can become easily a nightmarish task and can occupy a lot of your time. By the way, if you look into the I programmed this function before, so you could have just copied it. And I gave it to you. Okay? So you don't need to copy it. In the file that I gave you, you have this function. So you can just use it as it is. Okay? It's 5 o'clock. We'll stop here for today. Tomorrow we'll continue. I want to make another exercise with a while loop. And then we will get into blast. And we will rush over the other things a little bit so we can get into network analysis. Okay? Thank you very much. See you tomorrow. Yeah. So as I said, the function is there. Yeah. You just can compare it. Yeah, by the way, just a quick remark. If you make a mistake in your function, in your code, it will not allow you to source it. If you have a problem there, you will need to fix the problem first before you can make it available as a function in your global environment. It will not work if there's a mistake, because the computer will shout, "No, I don't know what to do. You wrote something that I don't understand."